Okay, so let's hope it doesn't crash anymore. Maybe it doesn't like solving NDPs. So we were saying that the objective is to learn the policy pi that maximizes the expected discounted return. If the NDP is non terminating, the discounting the rewards ensure finite return. That's the main issue. Discounting the return, which means multiplying the return by a factor that is below 1, ensures that in some time, it can be a very long time, okay, but ensures mathematically that in some finite time, the reward will become 0. This is just to make the problem tractable from a mathematical point of view. As engineers, we usually don't care because all of our tasks are achievable in finite time. Otherwise, we wouldn't care at all about the task. So this is the formulation, basically. The expected accumulated return in your whole lifetime given by a policy is defined as this, is the sum of the specific reward sample. This is R, not capital R. This is the specific sample of the reward you got in a given T step, multiplied by the discount factor, again, at that T step, all summed together for the whole lifetime of the task. But again, if it's infinite, usually there is a finite bound in which this term goes to 0, right? Thanks to the discount factor we introduced. So again, usually this factor is called also gamma because it is more or less always denoted by the gamma letter. Gamma basically means what we said. If it's 0, this term is immediately 0. So basically, you are extremely myopic. You only care about the immediate rewards. If instead it tends to 1, it means that I am more and more looking into the future. I am ready to, let's say, do an action that gives me a reward lower than maybe another action in this step, but that leads me to a higher reward in the future. Okay? The vast majority of the reinforcement learning problems, let's say, in a proper application of reinforcement learning, which means solving a sequential decision-making problem with rewards that are oftentimes delayed in time, such as getting to the end of the maze. The reward is at the end of the maze. Usually, gamma is high, 0.9, 0.99, okay? There are also situations in which it makes sense to have gamma low, but I would say they are the minority of the situations, okay? In most of those situations, your problem probably is best to be tackled by another approach and not reinforcement learning. That doesn't mean that the reinforcement learning won't work. Simply, it is more likely that you have also alternative approaches. So this is basically what all the reinforcement learning algorithms strive to maximize. This computation. They want to maximize this quantity. Okay? That's it. All of the reinforcement learning algorithms, regardless of the specific problem you are tackling. Okay? How to go there will be part of the next lesson. Okay?